In this video, I'm going to explain how I designed and installed some vent collars to go on my HydroHoist UL6600 that's used to hold my Catalina 275 out of the water. I was having problems with the hoist going down when the marina was subject to high wind conditions. So HydroHoist says that the boat should be positioned on the hoist so that the pontoons float in a level condition. So in other words, the same amount of pontoon is exposed at the front as it is at the back. So it turns out my boat was being positioned a little too far forward on the hoist, and so the forward end was down more than the aft end, and that's not good. I repositioned the boat on the hoist and got it to where the aft end and the forward end were the same height out of the water, but that didn't stop the problem of it going down. You can see in this video clip that with the wind blowing pretty good, the hoist rocks back and forth, and you can actually see the bubbling out from the vent on the bottom of the pontoon. I checked for leaks in the hoses, and I checked for leaks in the pontoons, and I also checked for a leak from the control unit, out of the vent pipe. So no leaks were found anywhere in the system, and the system was only 2 years old. So my conclusion was it's this rocking motion that's burping air out of the pontoons and allowing the pontoons to go down a few inches. And in my case, because I only had relatively little reserve buoyancy, then the pontoon would just go down halfway to a submerged condition. So I clearly didn't understand how the anatomy of the boat fit to the anatomy of the hoist, and so I ended up with a boat too far forward, and that damaged the front of my keel. So I was able to move the boat back far enough so that it floated level on the pontoons, but that positioned the sail drive propeller of the boat very close to the metal frame on the hoist. Here you can see how far back the bow of the boat is now from the dock, but that's the position that it needed to be in order to get the boat's weight in the right position on the hoist so it floated level. So it appeared that the solution, would involve a means to submerge the vent further below the pontoon so that when it burped a little bit of air, it wouldn't actually make the pontoon go down. So this is my concept, for the vent collar, and just made it out of 8-inch PVC pipe, and it extends down about a foot, and it has to conform to the shape of the bottom of the pontoon. This sketch shows the details of the vent collar, the dimensions also of the installation guide that went inside of the vent collar, so that the diver could use the installation guide to stab into the vent in the bottom of the pontoon to know it was in the right position before he pushed it up to where the adhesive contacted the bottom of the pontoon in the final position. So I was able to find a UL6600 HydroHoist that was on the shore, and this is a picture of the end of the pontoon, the aft end of the pontoon, near where the vent hole is. The vent hole is about a foot in from the aft end of the pontoon, and the bottom of the pontoon is concave. It's not flat. So the whole idea was to figure out how to contour the vent collar so that it would fit to the concave shape of the pontoon. So I just took a piece of manila folder out to where the pontoon was on shore, and I used some scissors and cut approximate shape, and then stuck it up there to the bottom of the pontoon to see if that looked correct. And then I used that template to calculate the offset, the amount of drop at each 10 degrees all the way around the 360 degrees of the vent collar. So this is a spreadsheet that I put together that calculates the cut down amount every 10 degrees around the vent collar. So then I measured around the circumference of the vent collar and took a tape measure and marked where it should be, and then I took a saber saw and cut a test collar down to see if I had it correct. So here's a couple of views of the test collar after I marked it and cut it to the right contour. So here's a couple of views where I took the test collar out again to where the pontoon was and positioned it up underneath, and then I used a shovel to push it up there while I took a picture, and it looked like the test collar fit very well to the contour of the bottom of the pontoon. So these images show the actual 12-inch long vent collars with the tops cut to the contour to match the test collar. And in these images you can see the vent collars with the installation aids. They were just cut from flat ABS plastic, 1/8 inch thick ABS plastic, and they were just put together loosely, and then I did fix them in place using the 3M4200 adhesive. Here is a 6-inch diameter bottle stabbing over the stabbing guides. So the material I was using, the PVC, is a Schedule 80 pipe, which is about a 1/2 inch thick, and this, you can see from this image, the landing area where the adhesive is going to be, the area that would need to be cleaned on the bottom of the pontoon. So it was decided that the vent collar installation would be done with the boat on the hoist, and it was done by a diver because the water was 50 degrees. He was wearing a wetsuit and a tank and insulated equipment. But the vent collar installation required to rig up some keeper lines around the pontoons, so that once the vent collar was lifted up into position, it could tighten up the keeper lines, and that would hold the vent collar up against the pontoon while the adhesive cured. Then had to clean the area of marine growth around the bottom side of the vents. We actually test fit the vent collars to the bottom of the pontoon before doing the installation with adhesive on it, to make sure that they look like they fit. And also had a a 15-foot long lanyard line to a little pad eye that I install on each of the collars in case the diver, lost his grip on the collar, and so it didn't go down to the bottom of the lake and get all dirty. And so the diver, I applied the diver was in the water, test fit him, looked like the fit was perfect, and I applied adhesive to the top of the PVC collar, and they handed it down to the diver, and he positioned it, made sure orientation wise it was in the right position so the contour would fit, and then pushed it up into the vent hole and against the pontoon, and then he wrapped on the pontoon while I tightened up the keeper line. Then we repeated that process, for the other pontoon. So the hoist operation goes up and down normally. These vent collars don't alter that at all. It's just that as air bubbles out, instead of it coming out right at the bottom of the pontoon, it comes out of the bottom of the vent collar, which takes part of a PSI of extra pressure, but that didn't seem to be a problem at all. And the vent collars do still burp some air when you grab the boat, when you pull the hoist back and forth, get it rocking, some air does initially burp out, but if it a few inches of air, say 2 or 3 inches of air, burp out of the vent collar, you've only lost like 2 or 3 pounds of buoyancy. Nothing compared to the 350 pounds per inch of buoyancy on the pontoons. So the vent collars have been on the hoist now for several weeks, and we've experienced some very strong winds, say 15 to 20 miles an hour with gusts over 30, and the hoist has not gone down at all. So this seems to completely solve the problem that I was having. I do think it's possible for any HydroHoist to be outfitted with vent collars like this. Maybe the contour for some other model other than the 6600 would be a little bit different, and but it's not that hard to measure the contour and figure out what it needs to be to fit, nor is it to install the collars. It'd be a lot easier if the pontoons were on shore as opposed to already in the water, but in my case it was not practical to remove the hoist, just to install the vent collars.